Okay, let's talk about how we can use this highest common factor to help with factoring. So you will recall from previous work the distribution law. Now we can distribute things that are outside a pair of brackets, right? We have, here's just an example. We've got a factorized form. We've got 5 outside of x plus 2. Now we know that we can, because of the distributive law, we can multiply what's inside the brackets by what's outside of the brackets. And we end up with what's known as the expanded form. And we've done a fair bit of this using the distributive law. I don't know why I wrote distribution law. Distributive is a better word. Distributive law. So it is about distribution, I guess. So I guess you could leave it like that, but I think this is distributive law. So we've done this lots, multiplying out brackets. Well, today we're going to talk about the reverse. We're going to go from the expanded form and we're going to end up with the factorized form. So let's think about this. What do we actually do when we are doing the distributive law? Okay, we are taking a pair of brackets, parentheses, and we are making them disappear. They're gone. We're taking a number out the front and we are multiplying it by each of the terms inside of the brackets. So obviously, when we go to the expanded form, we start here and go back in this direction. We're going to put some brackets back, and we're also going to end up with some sort of factor on the outside of the brackets. Okay, so let's talk about the process of actually using our understanding of the distributive law to go backwards, to work backwards. All right, so for factoring, there's a couple of steps. The first step is that we need to find the highest common factor of all of the terms that we're dealing with. Once we have the highest common factor, we will end up writing that factor down in front of a new pair of parentheses, the brackets, because we end up, whenever we're factorizing, making brackets. We then divide each term that we have by that highest common factor. Okay, so we will start with 12x minus 18. Now, I've already got the highest common factor there. It's pretty simple. It's a 6. Okay, so if I take 6 and I divide that into 12x, I'm just going to have 2x left, right? And I can do that. Here, look, 12x divided by 6. Well, 6 will divide into 12 and leave 2, and I'm just going to have 2x. 18 divided by 6 will be 3. So when I write this, I'm going to end up with 6. And you'll notice I had to write some brackets, right? Whenever we're factorizing, we always make brackets. And I'm going to have 6 outside of 2x minus 3, which are in brackets. Okay, so that seems pretty simple. So what happens then if we are dealing with more of these like non-numerical numbers? What if we've just got these unknowns? Well, here I've got f to the power of 3 plus f to the power of 9. Now, just as an aside, we know that we can add things that are the same bases and the same, but in this instance here, we're not going to worry about doing anything like that. We are just going to, we can't actually add these, they're different things. If they were being multiplied, there's a different sort of story, I guess. We're going to think about, well, what's the highest common factor here? We want to actually factorize this. Well, the highest factor of both of them is f to the power of 3. So, this one I haven't got filled out. I'll fill this out as we go. So, I know that I have to write my factor on the outside of the brackets. The highest common factor will be f to the power of 3. All right, so f to the power of 3 divided by f to the power of 3, because you've got to divide each of the terms, each of these terms that we have, by what we put outside of the brackets. F to the power of 3 divided by f to the power of 3 will just be 1. Plus, well, f to the power of 9 divided by f to the power of 3 will be f to the power of 6. Again, I'll quickly just scroll over here so that you can see what I'm doing. So f to the power of 9 over f to the power of 6 really means f to the power of 9 take... Oh, I'm not dividing by f to the power of 6. I'm dividing by f to the power of 3. It'll be 9 minus 3, which will be f to the power of 6. That's another one of those index laws that we've talked about in the past. Okay, and then that's it. This is my factorized form. Okay, so I've gone from my expanded form to my factorized form. We'll do one last example because these can be, they can get kind of biggish, I guess. Or there's a bit of thinking involved in some of them. All right, so here I've got a trinomial. There's the 3 parts to this, right? This works for any polynomial. If you're finding the highest common factor, you would have to find a factor that goes into all of the terms. You could have 4, 5, however many. You would need to find something that's not 1. 1 is not a great common factor when you're looking at things like this. Okay, so here I've picked out a highest common factor of 2x. And I can see that 2x will divide into all of these different terms. This one I have to be a little bit careful of because I've got a negative in here. I've got a minus and a minus as well. So let's just go with what we've got. All right, so negative 12x cubed divided by 2x. Well, if I'm dividing a negative by a positive, my answer will be negative. 12 divided by 2, so we do the numbers first, well, that will just be 6. X to the power of 3 divided by x will be x squared. Okay, so next one, plus 10, positive 10x squared divided by 2x, well that will just end up being 5x, and then 2x divided, negative 2x divided by 2x, that'll just be negative 1. That's all that I'll have left. Okay, so I've done that. And it worked, and that's okay. And you'll notice that all of the signs, negative here, positive here, negative here, negative here, the signs didn't change because I took out a factor that was positive. Okay. However, this trinomial here, this bit inside the brackets, the fact that it starts with a negative will make things trickier for us in the future. We really don't want to have negatives out the front. That is something that will be a problem. So what if, when I factored this, what if I took a highest common factor of negative 2x? Well, what do I end up with? Well, let's do that. So I'm going to do this again, but this time I'm going to use a factor of negative 2x. So once again, I'll need to divide each of my terms by my factor that's out the front. All right, so what will negative 12x cubed divided by negative 2x be? I might even make a little note of that just so you can see what's happening for this one. Negative 12x cubed divided by negative 2x. Well, my negative 2 and my negative 12 divide into each other, and a negative divided by a negative will leave me with a positive, and I will have 6. The x divides into the x cubed and just leaves me x squared. So my final answer will be 6x squared. So I'll write that in, 6x squared. Okay, well, I'm okay with that one. We might clear a little space over here and we'll do the next term. All right, so we've got 10x squared being divided by negative 2x. Well, I know that if I've got a positive and I'm dividing by a negative, I'm going to end up with a negative. So negative 2 goes into 10 and leaves me negative 5. The x will divide out this squared and just leave me an x. So I'm going to end up with a negative 5x. So I'll go minus 5x. And the last one is, I'm going to clear this one out. I've got negative 2x divided by negative 2x. And that whole thing will cancel out and just leave me 1 over 1, and 1 divided by 1 is 1. Positive 1 plus 1. Okay, so I want you to please note that when I had a positive out the front as a factor, none of the signs on my terms changed. But when I have a negative outside as a factor, all of the signs changed. They all swapped. I went from negative 6x squared to just 6x squared. Positive 5x to negative 5x. -1 to +1. So if your factor that you're taking out, if your highest common factor is a negative, then you have to be very, very careful that you're getting the signs correct. Okay, so that's how we can use that highest common factor to actually take out factors and factorize expanded form of trinomials, whatever polynomial that we're dealing with.